So in this video, we're going to do some applications or problem solving, story problems, word problems, whatever you want to call it, for an introductory algebra class here. So our goal here is to work on using variables in algebra to solve these. Some of these you might be able to solve by other methods, such as guess and check, but again, the goal is to use variables to get there. Okay, so number one here, we have Bob has a bunch of dimes and quarters in his pocket. The number of coins he has is 13. Their total value is $2.05. And we want to know how many of each type of coin does Bob have. So for a lot of these problems, there's going to be some kind of multiplication fact written down in generally three scenarios. So in our case, this multiplication fact here in sort of everyday language or sort of pseudo-type mathematical language, what we're going to have here is we're going to do something like number of coins multiplied by the value of one coin. So if you have like 12 nickels and they're worth 5 cents each, their total value is 12 times 5 or 60 cents. So you multiply these, you get total value of all the coins. So this is our general multiplication fact. Typically, these are things that are somewhat straightforward, or you learn a few of these to use in these types of problems. Okay, so once we get there, we're really going to write this down in three scenarios. And to do that, I'm going to really make a chart here. So my chart, let's make 4 rows so I can do then this 3 scenarios. So we have number of coins. We have the value of one coin, and we have the value, how about this, total value, no, that's not a good value, total value of all coins of that type. So what we're going to have here is we have really 2 types of quarters. Oh, I need one more column here. Sorry, we have 2 types of coins. We have dimes, we have quarters, and then we have the combined. So for our dimes, we know the value of one dime is 10 cents. I'm going to do this problem in terms of cents. I could do it in terms of dollars. That would introduce a lot of decimals. So $2.05 I'm going to write as $2.05 I'm going to write as 205 cents. And then I won't really need decimals at all. One thing we'll notice here, we know here that we know the value of one dime is 10 cents. Let's fill in what else we know. The value of one quarter is 25 cents. We have 13 total coins. So combined, the number is 13. And their total value, we're going to write as 205. Again, $2.05, but 205 cents matches 10 and 25. Okay. So now I need to put in some kind of an unknown. I'm going to tend to make one of the things I'm multiplying together my variable. You could make something like the total of the variable, but I think that generally results in a harder equation to solve here. So what I'm going to do is I'm going to make the number of dimes be x. And then what I get is x times 10. That'd be 10x. I like to write the number in front of the variable. So the value of all of the dimes I have is 10x. So we're saying here if I had 5 dimes, they'd be worth 10 times 5, 50 cents. But we don't know if it's 5 dimes. Maybe it's 12 dimes. Quarters, well, there's a couple ways to do this. So the way that I think generally these things get introduced as is I'm going to think, well, I have 13 total coins. X of them are dimes. So that means 13 minus X of them are quarters. So what I want to think is if you did X plus 13 minus X, X plus minus X would cancel and you'd be left with 13. So once you get there, I have 13 minus X quarters. That means the value of the quarters is 25 times 13 minus X here. And then what I can do is add up the value of the dimes plus the value of the quarters, and that should give me the 205. So after all of this, I get an equation. That equation is 10x plus 25 times 13 minus x, and that equals 205. And now you solve this for x. And the idea here is we don't have to think about where any of this came from at all. as long as we have some sort of note of what x is, this is the number of dimes, we can get x equals something and then go back and interpret the result. So now we need to solve this equation. To do that, I'm going to distribute the 25 first. 10x plus 25 times 13. I'm going to think of 13, let's see, I'm going to think of 25 really. 4 25s would be $1. Or, sorry, 4 quarters would be 4 things with 25 cents would be $1. So 4 times 25 is 100. So every 4 25s I get gives me 100. So 12 25s would be 3 groups of 4. That'd be 300. One more left over. 25 times 13 is 325. Minus, distribute the 25, I get 25x. I get 205. And now what I need to do is simplify this left-hand side. So 10x minus 25x combined equal negative 15x plus 325 equals 205. And I want to isolate the x, so I'm going to subtract 325 from both sides. And I get negative 15x equals, this is going to be negative 120. And then I want to divide both sides by negative 15. The negative 15s cancel, and I get x equals, the negatives will cancel here. 120 divided by 15 works out to be 8 here. You could go to your calculator. Here's the calculator I'm going to use here. Just do 120 divided by 15. It gives you 8 if you're not comfortable with that. So it gives me 8, and that's pretty much my answer, but I want to make sure I answer the question asked. So it says, how many of each type of coin does Bob have? So the 8, I go back and say that's the number of dimes. So that's 8 dimes. But then the number of quarters is 13 minus 8, which is 5 quarters. So that's 13 total. It's probably worthwhile to think about, does that actually add up to 205? So 5 quarters would be $1.25. 8 dimes would be 80 cents. $1.25 plus 80 cents is $2.05. So it does check out. Okay. So that's really a solution here. Let's do this in another way here. So I'm going to do my chart a little bit differently. So one thing I could have done, let's just start over. Do the whole thing over. So I'm going to do chart. So I did 1, dimes, quarters. I did 3 of these. Wait, how many horizontal lines did I have? I had 1, 2, 3 horizontal lines and 3 vertical lines. So what we had was dimes, quarters combined here, and then we have, let's see, number of coins. We had value of 1 coin, and then we had the total value of all the coins of that type. And what we had was a dime was 10 cents, quarter 25 cents. We had 13 total coins, and total value is 205 cents. So we started here, and this is still exactly the same as before. So number of dimes, I'm going to let be x. Number of quarters, again, there's 13 total. X of them are used up as dimes. That leaves 13 minus the x used up as dimes. So 13 minus x to be quarters, or I think I add these together and get 13. Value of the dimes is 10 times x. And now we can do this in a slightly different way. Last time we did 25 times 13 minus x equals the total value of all coins. What I could do is do 205 minus 10x should be the total value of the quarters. So you could set things up here. This total value of the quarters should be 205 minus the 10x. And then my equation, instead of being based off of this column, is based off of this row. So what I get is 25 times 13 minus x equals 205 minus 10x. So you could start there. Now let's look at the difference here in the equation. So essentially the difference between these two equations is this minus 10x on this side and the plus 10x on this side. Essentially I just moved the 10x over. Not a huge issue here, pretty small really, but looks a little different, and for some people that might make more sense. The stuff in blue probably makes more sense to me, but we can do the thing in green here too. So if we're going to solve this one, I would distribute the 25, which means 325 minus 25x equals 205 minus 10x. And now I want to move all the x's to one side. To do that, I'm going to add 25x, choosing to add the 25x because then I'll get a positive coefficient in front of the x, which just makes me more comfortable. You could add 10x, and it would look like the solution we had in the blue. In any case, this gives us 325 is 205 plus 15x. Now I want to get rid of this 205. I can do that by subtracting 205 from each side. I get 120 equals 15x. And then you divide both sides by 15. 15's cancel. And you get x equals 8. And that leads to, I go back up here, I get 8 dimes. And then there has to be 13 minus 8 is 5 quarters. So a slightly different way to do this one, but very similar. Third way, this one's going to feel a little bit different, but really be equivalent in the end here. What we're going to do is, let's see, we had dimes, quarters, and combined. And then we had number of coins. We had the value of one coin. And we had sort of the value of all the coins of that type. So what we had, here's value of one dime was 10 cents, value of a quarter is 25 cents, 13 total coins, and 205 cents was the value of all the coins. So same initial setup as before. I'm going to let x again be the number of dimes. 10 times x is the value of all the dimes. But then instead of doing the 13 minus x for the number of quarters, sometimes people will put another variable there like a y. You might do d and q for dime and quarter here. If you put a y there, you get 25y as the value of all the quarters. Now, what we're going to do is we have two variables, two unknowns, x and y, that'll give us two equations. So this first equation is the number of dimes plus the number of quarters. That has to be 13. Second equation is going to be the values add. You get 10x plus 25y equals 205. So we have two equations, two unknowns. These are linear. There's a whole set of techniques to solve these here. Right now, what I'd probably suggest at the level we're doing things is to do a substitution, that is, solve for one of the x or y in terms of the other. So when I have these two equations, I'm going to take this first equation here. So I have x plus y equals 13. I'm going to subtract x from both sides. That leaves me with y equals 13 minus x. Then I can put that 13 minus x in for y in this equation. So then what I'm going to do is say 10x plus 25, and then where I have the y, put in parentheses 13 minus x equals 205. I need to solve this. Now, essentially what we're doing is instead of writing 13 minus x, you're kind of solving for that from this x plus y equals 13 equation. So if you look at this equation, that's 10x plus 25 times 13 minus x equals 205. It's exactly the equation we have up here in the blue in the first one. So it's 10x plus 25 times 13 minus x equals 205. So then when you solve this, you're going to solve this exactly the same, and you'll get the same answer here. Essentially, well, actually, you'll solve this. I'm just going to put some steps. You solve this the same as in the blue above. You get x equals 8. And then once you do that, you can go back here and say y is 13 minus x. So y is 13 minus 8. That gives me y is 5. And so that's going to be 8 dimes, 5 quarters. Yeah, so that's my answer here. And basically all these questions, you don't any of these methods here. From here on out, I'm going to do one each just to kind of get through them and show the general setup. But you may see these done slightly differently, or prefer to like always put the y and then solve. That's going to work out just fine. Okay, next one. It says Brenda invested $1,000 into 2 bank accounts. She put some money into a savings account, which pays 2% interest. She put the rest of the money into a CD that pays 5% interest. So both really high interest rates for right now. She made a total of $38 in interest. We're going to assume this is over 1 year. How much money did she put into savings? So we need sort of our multiplications equation to base this all off of. And what we're going to do is the standard equation is amount of interest earned equals the amount invested, the principal, times the interest rate, like as a decimal, but it's generally thinking of percentage, times the time in years. Now this is over 1 year, so t equals 1. So our equation is really interest is principal times rate for simple interest. So that's really our key sort of equation here. So what we're going to do is we're going to make sort of the same chart or similar chart as to number 1. So we have a savings account, we have a CD, and then there's combined. And for each of these, we need the principal, the rate, and then the amount of interest that we earn. So what we know here is, okay, the savings pays 2%. I'm going to write that as 0.02. The CD pays 5%. I'm going to write that as 0.05. She put 1,000 into the two accounts. So the principal, we don't know each one individually. We know combined is 1,000. And the total amount of interest earned, that's the I, that's 38. Okay, so we have a very similar looking chart to before, different numbers, different equation, but same multiplication rule. And so what I'm going to think is, I don't know, these 4 boxes are empty. I'm going to look at my equation and say the principal is the one that I'm multiplying by something that I don't know. I mean, I could make x the interest, but that makes things a little harder. So let's make the principal x, then the principal for the savings x. Then the CD, the amount in the CD, well, if there's 1,000 total, the CD would then have to be 1,000 minus x. And then the interest amounts earned would be the rate times the principal. So that's 0.2x. Again, I like putting the sort of number in front of the variable just because I'm used to writing things that way. I know it's p times r. I'm really writing down r times p. Those are equivalent, though. And then the CD, the amount you earn there, is 0.05 times 1,000 minus x. X looks a little messy there. Let's extend that out. 1,000 minus x. Okay. Then the idea here is, well, if I earn $10 in the savings and 28 in the CD, that would add up to 38. So I should add these two amounts of interest to 38. So I get 0.02x plus 0.05 times 1,000 minus x, and that equals 38. Now, here I've got my decimals. I'd prefer not to work with those. You could. My general preference is to get rid of them right away. So I'm going to multiply both sides by 100 because I have 2 digits after the decimal point at most. So multiply the left-hand side by 100. And the right-hand side by 100 as well. And then this 100 will distribute to, I have 2 terms split up by the addition. So I get 100 times 0.02x plus 100 times 0.05 times 1,000 minus x equals 100 times 38. I'm just going to tack on 2 zeros to 38. That's 3,800 or 3,800. Okay, now what I'm going to do is 100 times 0.02, that's 2. I have the x. And then 100 times 0.05 is 5, and then I have the 1,000 minus x. So that equals 3,800. Now I have to distribute this 5 so I can simplify the left-hand side. 5 times 1,000 is 5,000, minus 5 times x is 5x. Scroll down a bit. Now I'm going to combine my x terms on the left-hand side. So 2x minus 5x is negative 3x, plus 5,000 equals 3,800. And then I'm going to subtract the 5,000 from both sides. So what I get is negative 3x equals 3,800 minus 5,000. That's going to work out to be negative 1,200. Now I have x times negative 3. So to get rid of this negative 3, multiplying by negative 3, I need to divide by negative 3 on both sides. That leaves me with x. Negatives cancel. 1,200 divided by 3, that's 400. So what I'm saying is we have $400 in the savings. CD would be 1,000 minus x, 1,000 minus 400, so it would be $600 in the CD. But let's see what was actually asked. How much money did she put in the savings account? So I'm going to make sure that's x. So my answer is there's $400 in the savings account. Okay, let's look at, for the sake of, let's look at this equation here. Whoops, well, erase that there. Let's look at that equation. How about in red? Write that a little bit more. What if we had solved that without multiplying by 100 on each side? So let's just write that up. 0.02x plus 0.05 times 1,000 minus x equals 38. So if we didn't multiply by 100 each time to get rid of the decimals, what would have this looked like? It's not going to be that much worse, a little different. So I'm going to get 0.02x. I'm going to distribute the 0.05 first. So 0.05 times 100, that's going to be multiplied by 5, but move the decimal point over 2 spots. That's going to be plus 50 minus 0.05x equals 38. And then I can add the 0.02 plus the negative 0.05. That's negative 0.03x plus 50 equals 38. And then subtract the 50 from both sides. And I get negative 0.03x equals negative 12. Divide by negative 0.03. Get negative 0.03. Just cancel x. And now this is why I don't like the decimals. I already did the 0.05 times 1,000. I worry that I kind of messed this up, that I'm going to get, maybe it's supposed to be 5 or 500. Like, that's correct, but I can imagine, I have to think a little to get the 50. In blue, the equivalent thing was 5 times 1,000, which is 5,000. Just feels a lot easier to do. Now, again, I have trouble 12 divided by 0.03. The negatives will cancel. If you wanted to do this, you could move the decimal points 2 spots on the top and bottom, get 1,200 over 3. You would get the 400 again. Or you go to your calculator and just do even negative 12 divided by negative 0.03. This gives you the 400 there. So either way works, really. But I somehow feel like with the decimals, this is just a little bit trickier to think about. Maybe disagree on that, but it's sort of just a preference thing. But just a trick is to just get rid of the decimals right away by multiplying by 100. Okay, next one. It says Liz went to the store, bought some apples and some oranges. Apples cost $3 per pound. Oranges cost $2 per pound. She bought 11 pounds of fruit and spent $26. And then we want to know how many oranges did she buy. So sort of our key multiplication equation here is we're going to get really pounds of, well, the type of fruit we're dealing with. And if you multiply that by the cost per pound, here, well, cost per pound, that really means multiply the number of pounds by the cost per pound, and that gives you the cost of sort of all of the fruit here. All the fruit of that type. So not just of 1 pound, but if you bought 4 pounds, it'll give you the cost of 4 pounds. So again, we have sort of a multiplication rule. So I've got apples, I've got oranges, and I've got sort of the combined here, and I have pounds. Let's rewrite that, so it's just for pounds. And then I have dollars per pound. That's the cost per pound. And then I have the total cost for that type. So what do we know? So we said apples cost $3 per pound. 3 there. Oranges cost $2 per pound. There's a 2 there. She bought 11 pounds of fruit. So pounds combined is 11. Don't know how that splits between apples and oranges just yet. And we spend a total of $26. So that's 26 here in the total cost. So this one's all in terms of dollars because there's no decimals for cents. If I had a problem where apples cost $3.48 per pound, I'd debate putting 348 here and converting everything to cents. Who knows? This way it doesn't really make sense because I'm just adding on zeros. Okay, so same thing as before. I'm going to look at my multiplication equation. I'm going to choose to get a variable to be one of the things multiplied together. So pounds of fruit, that's unknown. So then I'm going to make these x. And now, typically, I was making sort of the number of pounds of apples x because that came first. One thing that's sometimes a nice idea is you look at what we're asked for. How many pounds of oranges did she buy? Well, then I could make the number of pounds of oranges be x. It's sort of a choice here. It just means you don't have to do a little conversion at the end. So then the number of pounds of apples would be 11 minus x. Take away x of the pounds for the oranges, and that's what's left for the apples. Or think 11 minus x plus x gives me 11. Now the total cost then for the apples would be $3 times the number of pounds, 11 minus x. For the oranges, it's $2 per the x pounds. And then you're going to add this total cost column together. You get 3 times 11 minus x plus 2x, so however much you spent on apples, plus however much you spent on oranges, that should combine out to 26. Now we just need to solve this equation. So to do that, I'm going to distribute the 3. 33 minus 3x plus 2x equals 26. I'm going to combine together the like terms. Negative 3x plus 2x is minus x equals 26. And I want to isolate the x, so I'm going to subtract 33 from both sides. And then I get negative x equals 26 minus 33 works out to be negative 7. And now what I want to do is I have this negative here. So negative x is kind of weird. I can divide both sides by negative 1 or multiply both sides by negative 1. So what I'm going to do, I like to write this as division. Divide both sides by negative 1 gives you x equals negative 7 divided by 1 just is positive 7. So then there's 7 pounds of oranges, and then it would be 4 pounds of apples. So the idea of putting the x as the oranges is that's really my answer. So there's 7 pounds of oranges. Okay, let's, just for the sake of, one thing I want to focus on is what if instead of making x be the number of pounds, what if we made x the total cost of the oranges? So let's just see what that would look like here for the sake of, like why I don't like doing that. So you get apples, whoops, not oranges, oranges, and then combined. And then we have the number of pounds, we have the dollars per pound, and then we have the total cost. So sort of the given information in the problem is the 3, 2, 11, 26. I'm going to fill those in like before. And now when I go to make x, I wanted to do something with oranges, so we'll make x the total cost of the oranges. Now, this is where things get a little bit tricky, maybe. So the number of, let's see, the total cost, let's do it this way. So the total cost of the apples then would be 26 minus x. But then I have the relationship of the number of pounds of oranges times the dollars per pound, that equals x. And so if you think this through, then the number of pounds of oranges has to be x divided by 2. So I get this fraction here. And the number of pounds of apples has to be 26 minus x divided by 3. If you multiply 26 minus x divided by 3 times 3, just look at that. Well, this 3 I can write as 3 over 1, and then the 3's cancel. That gives me 26 minus x over 1, which is just 26 minus x. So that works out. But the issue now is, now I have to make this equation, pounds of apples plus pounds of oranges equals 11. So it's 26 minus x over 3, really bad 3, plus x over 2 equals 11. So now I have an uglier equation to solve because there's these fractions that pop up. Now, again, this is something you should be able to handle, but it's just more complicated, or at least it seems that way to me. Now, if I wanted to solve this, what I would look at is I have a denominator 3, denominator 2, common denominator is 6. So I'm going to multiply both sides by 6. I'm going to get the 6 times 11. And then I need to distribute the 6. Now, I'm going to get 6 over 1 times 26 minus x over 3 plus 6 over 1 times x over 2. 6 times 11 is 66. The reason I like to write this way is now 6 is 3 times 2. These 3's cancel. And I get 2 times 26 minus x plus 6 is 2 times 3. Now the 2's cancel on this side, so I get plus 3x equals 66. Now distribute the 2. I get 52 minus 2x plus 3x equals 66. Combine my x's. I get 52 plus x equals 66. Subtract the 52. And I get x equals 66 minus 52 is 14. But then my answer isn't 14 pounds. That's how much we spent on oranges. the number of pounds of oranges was x over 2. So I have x over 2, that's 14 over 2, that's 7. So I get the 7 pounds of oranges here, this way. So here, I wouldn't really suggest doing what's in red. I just wanted to show this so you can see sort of what that would look like if you made your variable the total cost here. One of the difficulties at the end, I do this last step. Now sometimes you might ask, what's the total amount spent on oranges? I'd really do the thing in blue in the end and just multiply by 2, number of pounds times 2. But look the same. So I generally like to make the variable something multiplied together so I don't have to do these divisions and get the fractions. Next one. Okay. This says Chris and Amy make a total of $60,000 per year. Amy makes $14,000 more than Chris. How much does Chris make? Okay. Now, this one I think is not really a multiplication question. So what we've got here is Chris makes some amount. Amy makes some amount. And what we're going to do is we're going to add really these values here, and that gives us sort of the combined amount. So what I'm going to look at is Amy makes $14,000 more than Chris. So the way this is phrased, I'm going to let the amount Chris makes be X, and then the amount Amy makes is $14,000 more than that. So that's X plus 14,000. And then the combined amount is 60,000. So I get an equation, just take the amount Chris makes plus the amount Amy makes equals the combined. And when I do that, I'm going to first of all combine, well, I can drop my parentheses for Amy's amount. X plus 14,000 equals 60,000. Then X plus X is 2X. And then we have to isolate the 2X. So I'm going to subtract the 14,000 from both sides. I get 2X equals 60 minus 10 would be 50, minus another 4, that would be 46,000. And then I divide by 2 to isolate the x finally, because it's 2 times x, so I divide by 2 to undo the multiplying by 2. Cancel the 2's, and I get x equals 46 divided by 2. That's going to give me 23,000. So this is really, my answer here is Chris makes, presumably in a year, yeah, $23,000. Now, well, maybe I should box the whole thing there. Now, what I would think about is if Amy makes 14,000 more, what I get is 23,000 plus 14,000. It's going to be 37,000. If you did 37,000 plus 23,000, that would give you the 60,000. This does check out. Next one. Okay. This one says, Emily wants to hand out 12 pounds of Halloween candy. She wants the candy to average $4 a pound. She goes to the store and finds that the good candy costs $5 a pound, and she notices that the bad candy costs $2 a pound. So she decides she will mix the 2 types of candy. How many pounds of each type should she buy? So this seems a little bit strange, bit of a mixture here. So what we're going to get here is, this is, I guess, a lot like the apples and oranges question. What we have is it's pounds times, pounds times cost per pound equals sort of total cost. So then what we've got is 2 types of candy, good, whatever that is, bad, less desirable but cheaper, and then we have combined. So what we've got, let's now read our information. So we want to hand out 12 pounds. Oh, I should have labeled my columns here first. So pounds, we have the dollars per pound, and then we have the total cost for that type or category. So we want to hand out 12 pounds. The combined number of pounds is 12. We want to have the candy average $4 a pound. So note here, what we're given is we want an average of $4 a pound. Okay, so we go to the store and we find the good candy costs $5 a pound. That's too much. So we'd really like this type of candy, but we're only really going to budget $4 a pound, what that comes out to. So we've got to mix this with something a little bit cheaper. So some type of less desirable candy we're calling bad candy costs $2 per pound. Okay, so what we're going to do is we're going to say, well, how many pounds of each type should she buy? So I can let X be either the good number of pounds or the bad number of pounds. I'll let X be the good number of pounds. And then the bad pounds, well, 12 total. X used up for the good. So I take away that number of pounds and get 12 minus X for the bad. And I could also take 12 minus X plus X. The X's would cancel, and I get 12. Okay, so the cost, I'm just going to multiply pounds times number of, or cost per pound. So X times 5, that's 5X. 12 minus X times 2. 2 times 12 minus X. Now, I want to add up this column is what I've done before here, but I don't have a number here. Fortunately, we can actually figure this out. 12 pounds times $4 per pound, that gives me 12 times 4, that's 48. So you have to do a little bit of work there. There's a new thing that the other questions didn't have to do. So now our equation is the 5X plus 2 times 12 minus X, that equals 48. Then we solve this for X. First thing I'm going to do is distribute the 2, so I can simplify the left-hand side. 2 times 12 is 24. 2 times negative X is negative 2X. And now 5X minus 2X, that's 3X. Plus 24 equals 48. And then I subtract 24 from both sides to isolate the 3X. 48 minus 24 is 24. And then divide both sides by 3 to undo multiplying by 3. So that'll isolate the X. 24 divided by 3, that's 8. So we end up with 8 pounds of good. 12 minus 8 is 4 pounds of bad. So we have 8 pounds of the good candy. And 12 minus 8 is 4 pounds of whatever the bad candy is. Probably, I don't know if I've ever seen candy I'd really call bad, but that's what we're calling it. Okay, last one here. So it says Shu has a bunch of pennies, nickels, and dimes. So 3 types of coins. And he has 5 more pennies than nickels and twice as many dimes as pennies. If the total value of the coins is $3.13, how many nickels does he have? So what we're going to do is set up a chart here. So we have pennies, we have nickels, we have dimes, and then we're going to have a combined category. So we have one more row than we're used to, but we're actually, if you read this, have a little bit more information. So what I'm going to do is I'm going to do number of coins. I'm going to do the value of one coin, and then the total value of all the coins in that group. So now let's read what we've got. He has 5 more pennies than nickels, but we don't know how many nickels yet, so let's leave that for a bit. Twice as many dimes as pennies. We don't know how many pennies. Let's leave that for a bit. Total value of the coins is $3.13. The total value of all coins is $3.13. We want to know how many nickels does he have. So I need to make one of these. Oh, sorry. I know other things here. Value of coins. So value of a penny, that's 1 cent. Value of a nickel is 5 cents. Value of a dime is 10 cents. I also don't know how many total coins. So I need to say it has 5 more pennies than nickels, twice as many dimes as pennies. So I have to make one of these variables x. If I read these 2 statements, they both have pennies in them. So I have pennies versus nickels, and I have dimes versus pennies. So because pennies are involved in both, I'm going to let the number of pennies be x, and then hope that that makes sort of the way that everything else works out a little bit simpler. So I'm going to say he has 5 more pennies than nickels. To work a little bit more, or a little bit harder here, that means I have 5 fewer nickels than pennies, so that's going to be x minus 5. I might sometimes plug in a value of x to see if this makes sense here. So where is this 5 minus x? Maybe it's x plus 5. Who knows? So what I'm going to say is, okay, let's suppose I had number of pennies. Suppose I have 8 pennies. How many nickels would I have? Well, if there's 5 more pennies than nickels, and I have 8 pennies, I'd have to have 3 nickels. So 8 minus 5, that would give me the 3. That works out. other piece of information, twice as many dimes as pennies, well, twice is 2 times the number of pennies. That should give me the number of dimes. So I should have twice as many dimes as pennies. Note here, we don't know the total number of coins, but we can get the value of each type of coin. So we have x pennies at 1 cent each. That's 1 times x, or just x. X minus 5 nickels at 5 cents each. So that's 5 times x minus 5. 2x dimes at 10 cents each. It's 10 times 2x, which is really 20x here. And then I'm going to add up the values of the pennies plus the value of the nickels plus the value of the dimes, and that should give me 313. So my equation is x plus 5 times x minus 5 plus 20x equals 313. And I need to simplify this whole left-hand side, so I'm going to distribute the 5 first. 5 times x is 5x. 5 times negative 5 is negative 25. And then I have x plus 5x is 6x, plus 20x is 26x. I'm going to add 25 to both sides to isolate the 26x. Gets me closer to isolating x. 25 plus 25 and minus 25 cancel. 26x equals, this is going to add to 338. And then I have 26 times x, so to undo multiplying by 26, I divide by 26. The x equals 338 divided by 26. This is one I might go to my calculator just to make sure I get that right. Honestly, if it was me, I'd probably try and do this in my head a bit, but it makes more sense to do it in your calculator. You get 338 divided by 26 is 13. So when I get done here, that means 13 is the number of pennies. So I have 13 pennies. 13 minus 5, that's 8 nickels. And I have 13 times 2, that's 26 dimes. Here. Now I should make sure I answer what's asked. So it says total value of the coins is 313. How many nickels does he have? So that's really, maybe I just box that. There's 8 nickels. Now, one thing I would do here is I might check that my sort of answer with the 13 pennies, 8 nickels, 26 dimes actually works out with what we're given. So we have 5 more pennies than nickels. 8 nickels, 5 more would be 13, checks out. Twice as many dimes as pennies. 13 pennies, 13 times 2 is 26 dimes, that checks out. Total value is 313. So the pennies is 13 times 1, that's 13 cents. Nickels is 8 times 5, that's 40 cents. Dimes is 26 times 10, that's 260 cents. 260 plus 40 is 300, plus 13, that gives me 313 cents, which is $3.13. So everything checks out, and I feel pretty good about that.